how do we troubleshoot Kubernetes clusters and resources running in those clusters? How do we provide support for clusters that we do not own, that we do not manage, and yet others might depend on us, others might expect us to help them out and to support the clusters that we do not own? We tend to have a lot of tools that help us manage our clusters. We have monitoring with Prometheus, Datadog, and a bunch of others. We have tools that help us with alerting. We have tools for policy management like Kyverno or OPA with Gateway. Generally speaking, we have abundance of tools that help us manage our own clusters, but there are very few that help us support other teams or even other companies, maybe our customers that are running our applications in their clusters, in clusters that we do not manage. But when I say that there are very few tools that help us provide support for Kubernetes clusters, that does not mean that there are none. There are a few, and today we are going to explore one of them called Troubleshoot. Let me explain what I'm looking for in those types of tools. They cannot be intrusive. I might not be able to install anything in those clusters. I might not be able to control those clusters. Those are not my clusters. I just need to provide support because maybe they're managed by some other team that has its own stuff, but they're looking for me to help them. Or maybe it's a customer that runs my software in their systems and I do not control those systems. And yet, if my application, the one that I gave them, the one that I sold them, and the one that I'm committed to support fails or starts misbehaving, I'm responsible for it. And that means that I do not have control over those clusters. I do not necessarily have even control on how that application is installed in those clusters, but I need at least two things. I need to help that somebody, that team or that company or that customer troubleshoot the issues, but troubleshooting cannot be, hey, go and figure it out. I am kind of responsible to give them means, to give them tools to validate whether my application in those clusters is misbehaving or no, and if it is not working properly, what might be the cause of that. And if troubleshooting fails, if they cannot figure out through the means that I provide what's wrong, I expect them to give me all the information that I might need to be able to help them out, to be able to figure out what's wrong. So there are three critical aspects when trying to provide some kind of support. It cannot be intrusive. I cannot guarantee that I should be able to install stuff that I might need to troubleshoot their issues inside their clusters. It needs to provide some troubleshooting capabilities so that the need for them to contact me is lowered. If I can give them means for those customers, for those teams to figure out what's wrong by themselves and fix it potentially, then my job will be easier. And finally, I need to provide tooling for that team, for that company, for that customer to gather all the information that I might need before I engage with them and we try to figure out what's wrong together. We are yet to see whether Troubleshoot fulfills all those requirements or all those needs, whether it has the capabilities that I need or that you might need. We are going to see that later. Right now, we are going to jump into the hands-on session and see Troubleshoot in action before we go back to discuss it and see whether it might or might not be a good fit for you. This video was sponsored by Replicated. They did not influence the contents of this video, they haven't even seen it before it was published. They recognized the value of this channel and decided to sponsor a video. So huge thanks to Replicated for helping out. The link with additional information about Replicated is in the comments, and if you're a software company and you would like to sponsor a video or the whole channel, please let me know. My contact details are in the description. I already created a cluster. Today I'm using Kind, but everything I'm showing you should apply to any type of Kubernetes cluster, and I installed the demo application. That's it. That's all I did in advance. Now let's install Troubleshoot, and it consists of two components. One is called Preflight and the other one is called Support Bundle. We are going to install them as Kubernetes add-ons. I'm getting slightly annoyed that every single tool gives me a new CLI. If it's a Kubernetes type of tool, providing an add-on to kubectl so that I can have one CLI to do everything related with Kubernetes is kind of awesome. So big plus on that one. Now let's go back to installing. I'm going to use Crew to install it. If you do not have Crew, you might want to install it. It's awesome. Probably the best way to install plugins into kubectl. The link is in the description. So it's going to be kubectl crew install Preflight, and then the same command but for the support bundle. That's about it. It's as easy as that. Now before we proceed, there is a warning or the first potential negative point for Troubleshoot. I could not manage to make it work on my M1 Mac. I'm not sure whether it's me or it doesn't work on new M1 chips, but you might want to be aware of that. As soon as I switch to an Intel computer, in my case iMac, but basically any other, it worked like a charm. So I'm not sure whether it's me or it doesn't work on M1, but that's something you might want to double check depending on what you're running. Let's start with the first of the two. It's called Preflight, and it allows us to provide means for others to troubleshoot, to figure out whether everything is in order or what might be potential problems without really coming back to me. When providing some sort of support, we want to enable others to figure out most of the things themselves and come back to us only when there is no better option, when there is no better alternative. And Preflight does just that. So let me run it and see the outcome. Later on we are going to discuss how to write the manifest, but for now let me just run it and see what we'll get. And we can see on this small sample that my cluster is a disaster. And it would be reasonable to expect that if there are known issues with my setup, that I should be able to fix it myself before I get in touch with somebody else to give me a hand, especially if there are some sort of guidelines of what I should do next to remedy the issues or to make sure that the cluster, the system that I'm running, complies with the requirements of the application that I'm running in that cluster. First of all, we can see that the Kubernetes version of my cluster is not the supported one, or at least not the one that meets requirements of the application or the system or the platform that I'm supposed to be running in that cluster. On top of that, Kubernetes distribution that I'm using is not the one supported by the vendor. Further on, I do not have 3 nodes in that cluster, which is a minimum for high availability. Those nodes do not have enough allocatable RAM. The only thing that meets the requirements, the only thing that is okay, is the amount of CPU I have in that cluster, at least so far. And then we come to another potential issue. It says analyzer failed. I'm not sure why it failed or what the issue is. Actually, I do know, but I'm pretending I don't. We're going to fix it soon. And the last requirement for this system, for this cluster and this application in the cluster to run successfully is the storage class, and I'm meeting that requirement. My cluster should have the default storage class, and it does have it. Now let's look at the manifest and see how all that happened. How did the tool know what are the requirements, what I need in my system to run successfully? We can see a bunch of analyzers in this definition. Each of them is a certain type and has certain outcomes. The first one, for example, is the cluster version. And the outcomes say that it should fail if the version is below 1.19 and that it should give us a warning if it's below 121. Finally, if it doesn't meet any of those criteria, then it's a pass, it is successful, and the system moves into evaluating the next analyzer. And that one is distribution that validates whether the Kubernetes we are running is one of the supported ones or not, which contains only passes or failures, meaning that if it doesn't mean any of the passes in the outcomes, then it's a failure. In other words, in this case, if it's not GKE or AKS or EKS or K3S, then it's a failure. And it continues with node resources. There are a couple of them, one for memory and the other one for CPU. And the last one in this definition is the deployment status, which says, hey, if you have less than 1 replica, meaning 0 replicas of a specific application, then it's a failure. And if you have less than 3, then it's not such a good thing. It's not a failure, but it's not good, so it's a warning. And finally, if it doesn't meet either of those, then it's a pass, right? So you're all good. You have 3 replicas or more. It's successful, brilliant. I'm proud of you. Actually, there is one more hard to see, which says storage class. And since it doesn't have any argument, it means, hey, you need to have a default storage class, whichever class you want, but it must be the default one. Now let's go back and try to fix the analyzer failure that we had before. I don't mean failure of the system, that it doesn't meet the requirements, but one of those analyzers did not work. And that one is the deployment status, which has the namespace specified explicitly in the manifest, but for that one to work, we need to specify the namespace in the kubectl command as well. So let me run it first and confirm that that's really true, and then we are going to talk about it for a second. And this time it worked. If you take a look at the DevOps Toolkit status, we can see that it's not an error of the Preflight, of the plugin itself. Now it's working correctly. And that is the second negative thing I have about Troubleshoot. What is the point of specifying the namespace explicitly in the manifest if we need to do it through the CLI as well? And how would we proceed checking multiple applications running in different namespaces? I cannot have more than one namespace specified when I run kubectl, and that's probably the purpose of having it explicitly set in the manifest. So that's a glitch, let's say. Maybe it's a bug, I'm not sure. But that's the second thing I don't like so far. Now you might be wondering, hey, how did you know which analyzers to specify in that manifest? And the answer is simple. I checked the documentation, and if you go to the docs, we can see that there is a list of all currently supported analyzers. They can be extended if you're brave, and especially if you want to contribute to the project. In any case, you have a set of predefined analyzers which you can consult in the docs, and if that is not all you need, then contribute to the project, and then the project will continue growing, and that's how open source works. The good news is that if you're lazy and you don't want to contribute, the analyzers that they have are quite extensive, and there's quite a lot of them. I mean, there is not hundreds, but more than enough for the majority of use cases. Now I'm going to pretend that I'm a person who needs help from somebody because the application doesn't work, the system is misbehaving. I saw the analysis. I do not yet need to contact anybody from support. All I need to do is try to fix those issues myself, especially since descriptions are giving me tips of what I should do. So I'm going to destroy my cluster and start over. Now in a real world situation, you would not destroy your cluster. You would update your cluster or upgrade it. You would modify it. But since this is a local cluster, I'm going to destroy it first, and then I'm going to create a new one that hopefully meets most of the requirements. So let me show you how will the new cluster look like. To begin with, I changed the image. So now it is Kubernetes 1.21. That should meet one of those requirements. And I added 3 worker nodes so that it meets the second of the requirements, meaning that there are 3 nodes in a cluster. Luckily for me, Kind allows me to do that. And if you're not familiar with Kind, you should be. Check it out. There is a video somewhere. It will pop up on a screen. And with that in mind, I will create the new cluster and I will deploy my application. And then I'm going to run the analysis or Preflight one more time and see whether I fixed all or most of my issues. So let's see whether that's true. I'm going to execute kubectl preflight and let's see the outcome. This time I have only one failure and all the rest of the analysis is either a complete pass or a warning, and I can live with warnings. They're not necessarily ideal, but hey, they're not failures. What matters is that there is only one failure, and that's the one I can do nothing about. And if I read the description of that failure, I can see that, hey, Kind is not one of the supported clusters, but if this is a local cluster, then it shouldn't matter as long as you're nice and you do not run Kind in production. The experience so far was absolutely awesome. I could troubleshoot my issue, see the suggestions, how I can fix them, and I did not need to contact support at all. But imagine that my application is still misbehaving or that there is something wrong in the system. Preflight or troubleshooting myself did not really fix all the issues, even though everything is yellow or green. So I need to contact support. What should I do? I can call them and say, hey, there's something wrong in my system. And they might respond in different ways. And they might say, so what? There is nothing we can do. This is not our cluster, this is your cluster, we do not have access to your cluster. How can we help you? By you saying there's something wrong without giving us additional information. And the key in that conversation is in the phrase additional information. If we want others to help us without giving them access to our system, to our cluster, we need to give them more information. We need to give them means for them to try to help us out, to figure out what's wrong. So we are going to create a support bundle, and that bundle will contain everything that they might need to debug the issue and help us out. Now, the support bundle manifest can contain the same analyzers as Preflight, which in this case I did not include because the outcome would be the same. We would see the results on the screen. What matters here, what is special about the support bundle, is that we can include collectors. Collectors are entities or modules that will collect certain types of information, and I am in control of what information is collected, or maybe support department or support team or people told me which collectors to use, and in this case I specified a couple of them, and that's cluster info, cluster resources, and the logs of that specific application. Now, just as with analyzers, there is a bunch of different collectors I could choose from, and I can go to the documentation and see which collectors are available. I picked 3, there's much more, just check it out yourself. There's a decent amount of them, and they cover very commonly used use cases. Not necessarily everything you can ever imagine, but if that happens, you know what to do. It's open source, contribute. So all I have to do really is execute yet another command. In this case, it will be kubectl support bundle, and then specify that manifest and wait for like half a second or something like that, and see the results. The output is not very informative, and if we ignore the warnings from Kubernetes itself, the only thing that we got is the path to the file that was generated. It's a tar zip file, so let me store it in a variable and then uncompress the file that was just generated and take a quick look at what we got. There is a cluster info directory and cluster resources and a log file. Those 3 correspond with the 3 collectors that I specified. And you can probably guess from the names what they are. Cluster info gives us, well, information about the cluster, you know, the version and a few other information. It's more or less what we would get with kubectl version command. Resources part is actually much more extensive, and if we take a look at what's inside of the directory, we can see that there are deployments and events and ingress and nodes and basically all the Kubernetes resources that you might or might not be running in that specific namespace. So let's take a look at one of those, let's say pods of the production namespace. And we can see all the information about every single pod in that namespace. Essentially, it's similar to what we would get if we would execute kubectl, get certain pod, and then output to JSON, with a small but very important difference. The values of some of the fields are hidden to prevent others from finding out our secrets, from seeing things that they should not see. And all the other resources are in that directory as well, like for example ingress. Let's take a look at ingress and see what we'll get. And as you can see, there is the information about the ingress resources in that namespace. And the last collector that I used today is the one that fetched logs. And I can see the logs of all the pods that meet certain criteria, whatever the criteria is. Now, since I mentioned that values of some fields are hidden, let's take a look at the docs. What do they say about it? And the section is reductors. And we can see that there are quite a few of those. Some are baked in and some we need to specify explicitly. They're grouped into database connection strings, AWS credentials, connection strings, IP addresses, passwords, API tokens, and usernames, which are the most common things that we want to hide from others. So what we saw with support bundle is that we can define what collectors should be used, which data should be collected. All that is compressed into a single file, which we can send to others, to support guys, the people that want to help us out, or maybe they don't want to help us, but we are paying them to help us. And all that is mixed with security so that those same people cannot see things that shouldn't be seen. So right now I would write a new email or open a ticket and attach that bundle and say, hey, those are the problems I'm experiencing. Here's the support bundle that should contain all the information you need. Please help. If, as a user, you do that, you bundle all the information somebody needs and send it to that somebody will be thankful and will be able to help you faster. Or, more importantly, if you're the person who provides support, who helps others, then you should be promoting tools like this. You should be defining those manifests and giving them to others and say, hey, those are the preflights you should run whenever you're in doubt or whenever you have an issue. And if there is nothing helpful over there, if none of the recommendations of what you should do are useful, then you should create a bundle, send it to us. Here are the manifests. Those are the things that we need. Please run this and send us the output. That's a very effective way to establish collaboration between different teams that do not necessarily have access to each other's systems. One team is helping the other without having the access, but by having all the information or potentially all the information that is required to debug an issue and help out. I'm very impressed by Troubleshoot for a couple of reasons. First of all, it meets all the important requirements. It is not intrusive. It tries to help others set up the system in a way appropriate for certain application or certain platform or whatever they're running. And if that does not help, if following certain best practices and meeting certain requirements does not fix an issue, then that somebody can create a bundle and send it to me or whomever is supporting them. So it is not intrusive, it provides help when troubleshooting something, and it collects all the necessary information that somebody else might need to have before diving into the mess that I created or somebody else created. Essentially, it is doing exactly what it should be doing with a few minor glitches that are not really that relevant and shouldn't prevent anybody from using it successfully. Another thing I like about Troubleshoot, apart from being open source and free, is that it is obvious that it was created by a company or a team that was facing those issues. This looks like a tool that was created for a specific internal purpose and open source so that others can benefit from it. And that's absolutely amazing. Hey, if you have something that is very helpful to you and it is not really your core business, open source it so that others can contribute, help you out, and at the same time benefit from that something. All in all, it's free, it's open source, it's doing what it needs to be doing, and if you're one of the persons that is providing support or one of the people that asks for support, this is a great fit as long as what you need is Kubernetes. This tool really does not go beyond Kubernetes. It will not help you troubleshoot or collect information about your infrastructure or whatever else you might be having. But if Kubernetes is your thing, this is tremendously helpful.